Hello, my name is Andrei Yesipov, and my final project for this course is a big data case study in social media. Social media companies hold an immense corpus of data that essentially mirrors how people interact with each other, and at the heart of these interactions lies very invaluable information about what individuals and societies hold most important. In some cases, the term big data is often directly attributed to the volume of data and the fast rate of data flow in today's social networks, like Facebook, Instagram, Twitter, YouTube, and others. And by running various analytics techniques on social media data, big data applications in different industry sectors start understanding how the content contained in the interactions between people on those social media might affect the business performance and people's view of the company, product, or person. Additionally, analysis of users' content allows companies to focus on actionable information from the messages that users post on social media, such as tracking negative or positive sentiment about a brand, as this can threaten reputation and ultimately affect revenue. There are many practical applications to big data in social media, such as analyzing markets and predicting consumer behavior. Another application is correlating content to demographics of users, such as age, gender, marital status, geographic location, income levels, education, and so forth. This is very beneficial for advertisers since they can react in near real time and adjust marketing campaigns to make more revenue. Based on this information, the retailer might decide to target the candidates with discount offers through Twitter, Facebook, Instagram, and if analytics show the uptake and comments are bad, the offer can be refined to improve performance. Furthermore, social media analytic tools mean that businesses can parse mounds of unstructured data to find meaningful information that can guide decisions and actions. Through analysis of statistical data such as impressions per post, audience distributions, interactions on mobile devices versus desktop devices, as well as transactional history, a company can measure the effectiveness of its social media strategy for promoting brand recognition and loyalty. However, as companies like Facebook, Twitter, and Instagram continue to monetize their offerings, it's very likely that the benefits that big data will have for social media in the future will become even more personalized. And one study published by researchers from Cambridge and Stanford universities show that Facebook can use its data to predict people's personality with more accuracy than close friends and families. Even every like, share, follow, and comment is basically data that tells social media companies what a person likes or dislikes, what person's action will be, which brand the person will support or react to, and whether the person is likely to buy a particular product or not. And this situation will only intensify as people become more and more reliant on social media platforms for accessing and sharing information. Given the recent political events, for my project I decided to better understand the real-time sentiments of the online public on Twitter towards US President Donald Trump and Russian President Vladimir Putin by analyzing users' tweets as they get posted in real time. Both Trump and Putin have been prominently featured in the news media over the past year, so mining Twitter to get general public sentiments on each of these individuals will help better understand how both of them are being perceived by the Twitter community. We can then use this result to reason and extrapolate that sentiment to better understand how the public reacts to these individuals and whether current events have an effect on general public sentiment. For my project, I decided to learn and apply Azure Machine Learning and Azure Streaming Analytics stack to help me analyze posted tweets in near real time that have the @real Donald Trump mention and hashtags Trump and hashtags Putin in the tweets themselves. Since I already had an Azure subscription, it was a perfect excuse for me to try these technologies. For this project in particular, I explored and employed the following major technologies in order to create an end-to-end solution. The first one is the Azure Event Hub. It's really a hyperscale data ingestion service that I use to collect real-time tweets sent by Twitter application. Next, I heavily used and relied on Azure Machine Learning Studio, which is a managed cloud service that enables to easily build and deploy predictive analytics solutions to create a sentiment scoring model for my project, which essentially assigns a positive, negative, or neutral sentiment to each tweet. And I trained that model based on the data set that I obtained from the Sentiment 140 website, which has a collection of tweets that already have a sentiment value assigned to them. Next, I relied on Azure Streaming Analytics, which is an on-demand real-time analytics service that allows to easily develop and run massively parallel real-time analytics to ingest tweets from the Azure Event Hub, where I store all my tweets, and apply the machine learning model to assign the correct sentiment to those tweets, and then finally store those results in an Azure SQL database, which essentially is a SQL database but in the cloud. And finally, I used Power BI, which is a suite of business analytics tools that helps deliver insights throughout the organization. And I relied on it to visualize and analyze the output of tweets with assigned sentiments for both Trump and Putin. And all of these projects integrated nicely together, so it was real fun using them. So here's the high-level overview of the data flow in the solution that I developed. So first, I used my existing Microsoft Azure subscription to create an Azure Event Hub that would process the tweets that were sent from my Twitter application based on my selected keywords for Trump and Putin. I would then feed that data from the Azure Event Hub to Azure Stream Analytics, and then apply a machine learning model that I developed in Azure Machine Learning Studio that would assign a sentiment, which is either positive, negative, or neutral, to each of the incoming tweets. And I used the Sentiment 140 dataset to train that model. And finally, I would then save the output of the Azure Stream Analytics in a SQL Azure database, and then visualize the results in Power BI, which I'll show later. So I started off by creating an Azure Event Hub. So to reiterate, Azure Event Hub is a hyperscale data ingestion service that collects, transforms, stores millions of events. And it's a very distributed streaming platform, and it provides low latency, configurable time retention, and all of that allows for ingress of massive amounts of data into the cloud. The process of setting up the Azure Event Hub was very straightforward. It really involved just a couple of clicks in the Azure portal, and all I really had to do is then create an access policy for any particular application to start writing data to Azure Event Hub. So the configuration and the setup was very straightforward. Then, in order to retrieve the tweet data about Trump and Putin, I first had to sign up for a Twitter developer account and create an application that would leverage this data. I then obtained all the required API keys and access tokens that I would need to use by the Twitter in the Twitter application to be able to retrieve the tweets from Twitter about Trump and Putin. For the Twitter application, I downloaded a publicly available Twitter client application, which is written in C#. And all it really does is just connects to Twitter using Twitter's streaming APIs and collects tweets about Trump and Putin, which I configured in the application themselves, which I then sent to Azure Event Hub that I set up. And before I ran the application, I changed the app settings to make sure that they use the application and access tokens settings that I configured for my Twitter application in the previous step, and that it would collect the topics based on the @RealDonaldTrump and #Putin and #Trump topics. And finally, since it was a C# console application, it was very easy for me to publish that console application as an Azure web job directly from Visual Studio. This allowed me to effectively run this console application on a continuous basis from the cloud, which made it a lot simpler to execute this program on a continuous basis. Next, I started building up the machine learning model using the Azure Machine Learning that would assign sentiments to tweets that I would collect and store in the Azure Event Hubs. But before I could do that, I needed to train this model on the existing data set. So in order to do that, I got the data to train and test the model with from the Sentiment 140 dataset, which is a publicly available dataset that comprises of approximately 1,600,000 automatically annotated tweets. And really, the dataset is very straightforward. It just contains two columns, the text, which is the body of the tweet, and the assigned sentiment label with the higher value reflecting a positive sentiment, and with a low value, such as 0, indicating a negative sentiment. So after bringing in the data into Azure Machine Learning Studio, I pre-processed the tweets using a Python script module to replace punctuation with spaces and convert tweets to lowercase, and then returned that in a modified pandas data frame. So I did all that to make sure that it's a little bit easier to work with the data once I get to actually training the model. Also, I did some research online on how to go about training models based on unstructured data. It was recommended that I mark the tweet text column of the dataset as a non-categorical and a non-feature column in order to facilitate analysis down the road. And then I applied the feature hashing module, which is based on a Vaupal-Wabbit text classification framework, to transform this dataset into sets of features represented by integer values. Next, I added filter-based feature selection module to select a subset of features from the large collection of hashing features, and it really allows you to determine which subset of features to use that will have the highest predictive power. And I used the chi-squared score function. Before training the model, I split the dataset. I used 80% of the dataset for training and 20% for testing. So, which is basically one of the classic setups for training machine learning. And I used support vector machine algorithm to train the model. After I ran the model, I got an accuracy of around 77% using the algorithm, which means the model accurately assigned the correct sentiment to the tweet 77% of the time, which is pretty decent. So I decided to not optimize it further and just stick with that accuracy. Finally, I saved my trained model and then created another experiment and converted that experiment to a web service, so I can feed the data directly from Azure Stream Analytics, and then assign the appropriate sentiment to the tweet based on the model results. And as a final step, I added an R script to assign a tweet a positive sentiment if the model's probability that the tweet was positive was greater than 0.60%, and negative sentiment if the probability was less than 45%, and a neutral sentiment if the probability was in between these two values. Next, I proceeded with setting up Azure Stream Analytics directly from the Azure portal. I created the Stream Analytics job and specified Azure Event Hub that I created earlier as the input source of the tweets, and then specified Azure SQL Database as the output of the Stream Analytics job. And that's where I would store the tweets with the assigned sentiment values. And I used the following SQL query to retrieve results and store them in SQL database. Then the next crucial step was adding the machine learning model that I developed previously as a function for the Azure Stream Analytics, which would take the inputs that would fed into the Stream Analytics engine and then assign the sentiments to each tweet based on that machine learning model. And lastly, I configured the output to store the data in the SQL Azure database. Once everything was configured, I started the Stream Analytics job to start generating data and insights. And it was very easy to monitor the data as it was coming in real time. Now that I had the data being written to the SQL Azure database, I could start visualizing the data, and for that purpose I used Power BI. Particularly, I downloaded the Power BI desktop application and then connected it to SQL Azure database to visualize the results. And I created the following Power BI dashboard to help better understand user sentiments based on tweets about Trump and Putin. So to my surprise, the general sentiment towards Trump was generally positive. Around 50% of the tweets were marked as positive. And the other 2/4 of the tweets were split between neutral and negative. And the general sentiment towards Putin seemed to be mostly neutral and negative. However, the sentiments were based on far fewer tweets when compared to Trump's, as indicated by one of the charts. I then proceeded to analyze whether Twitter users from particular regions had particular sentiment preference towards both Trump and Putin. And for that, I used the Bing map visualization and plotted the average sentiment value based on users' time zone. So an interesting finding was that on average, Twitter users from Saskatchewan seemed to have the lowest sentiment score for tweets about both Trump and Putin. So this was a bit interesting. And it also appeared that Twitter users from Korea seemed to have the highest average sentiment value of basically 92% of tweets being positive when compared to other languages. That might indicate that folks in Korea generally perceive both Trump and Putin in a positive fashion. And lastly, I added a few word cloud visualizations to see if words from tweets about Trump and Putin appear more frequently than the others. Some interesting words that jumped out were Senator Gillibrand, CNN, Senator Warren. I then looked at tweets with just positive sentiments for Trump to see if certain words jumped out there, but couldn't really find any obvious patterns that would occur more frequently than the others. I also examined tweets with just negative sentiment for Putin to see if certain words jumped out from those tweets, and words like Syria, Russia, RT, which is Russian Times, military, Mideast seemed to jump out. This could be indicative of public's opinion towards the recent political developments in the Middle East, which I thought was pretty interesting. And to sum it up, this was a really fun project to undertake because it really gave me the opportunity to examine how various Microsoft products can be used to build an end-to-end streaming and predictive solution. This also was a great opportunity for me to learn and have a practical understanding of how all of these different products work and how they integrate with each other. This was the most fun part of the project, however, it was also the most challenging part of the project at the same time, since I had to learn about different products and how to make them work with each other. And I can also see how the solution would get a lot more complicated if I used some other product outside of Microsoft ecosystem, such as Apache Spark or Storm. Yeah. So based on my project and my experience, I would highly recommend using a combination of Azure Event Hubs, Azure ML, Azure Streaming Analytics, and Power BI to create near real-time predictive scoring pipelines based on social media data and be able to visualize the results using very rich dashboards in Power BI. Thank you for listening.